Hello, welcome back to another video. In this video we're going to be looking at what's called Cramer's rule, and it is another way of solving systems of equations. It's pretty effective if you don't really care what certain variables in your solution are. Like say you have a system of equations and you just want to find x in the equation. It is really good at finding just x and not y. Um, so I'm going to just describe how we use Cramer's rule for a two-variable problem. I'll do a three-variable one in the next video, but essentially I'm just going to be having x's and y's. So a system of equations, a linear system of equations, I should say, ax plus by, where a and b are numbers, is equal to some number r, and then cx plus dy, this is equal to some number s. Okay, so these are all just placeholders for numbers. This is a system of equations in two variables because I have x and y are my variables, and then all the other things, while technically being variables, I'm saying those are fixed numbers. Okay? And what Cramer's rule says is that you can actually find x and y just using determinants. Okay? And it's actually pretty cool. I'm not going to justify why it works because it's a little complicated and I don't want to lose a bunch of you. But it does work, and essentially it tells you what x is you take and you are dividing by the determinant of the matrix. You just throw these coefficients in, okay? A, B, C, and D. So divide by that determinant, and then on the top, what you do is another determinant, okay? But since x is the first variable in your equation, it's the first variable you're trying to find, you take the same determinant, but you replace the first column with these numbers, r and s. So you put r and s here, and then b and d here. Okay? Again, let me highlight why that is. So, well, not why this works, but at least why we're doing this is, so you divide by the determinant of just these coefficients, okay, a, b, c, d, and then since x is the first variable in your equation, you replace the first column of that with the numbers that are over here, okay? And this also works, you can find y with this as well. It tells you that y is going to be equal to, again, you divide by the determinant, a, b, c, d. So this is where I have this line here. I'm just meaning it's a fraction of two numbers, right? Determinants are numbers. Okay, so I do the same determinant on bottom, but since y is the second variable, what I do is on the top, I just put the same thing as what's on the bottom, but I replace the second column with r and s. Okay, so a, c stays the same, but then r and s switch. Okay, so Cramer's rule tells you what the solutions are for a system of equations. You can find x and y using this rule. Okay, so what I'm going to do is I'm going to do an example of this so that hopefully you can kind of get a little bit more comfortable with it. let's say we want to solve the system that I have here. So I've got, let's say we've got 2x plus 6y. This is -1. And then x plus 8y is equal to 2. Okay, so we want to solve this system. And there's other ways you can solve systems, right? We've gone over a lot of them. You could do substitution or elimination, or you could set up an augmented matrix where you put these coefficients in as your matrix inside of your matrix, and then these two numbers on the last column of the matrix and do row reduction. That would work as well. Or you could write it as a matrix equation and solve by finding the inverse of the matrix and timesing both sides by the inverse. There are so many ways you can solve systems of equations, and hopefully you're kind of seeing that. But we're going to solve this by Cramer's rule, okay? And so what Cramer's rule says is to find x, I'm going to do, well, the thing that goes on bottom is the determinant of the matrix of coefficients. So I just do 2, 6. The number in front of the x here is 1, and then 8. Okay? Make sure if there's minuses here that you put negative numbers in. Okay? And so that's what's on bottom. We just take the determinant of the matrix, and what goes on top is another determinant. But since x is the first variable, we replace that first column with these numbers here. So I put in -1, 2, and then 6 and 8. Okay, so I just keep the same determinant as what's down here, only since x is the first variable, you replace the first column of this with the numbers that are over here. Okay, do I have another color I can use? I would like to highlight that a little bit better. There's my handy dandy red. So that column, this first column, gets replaced with those two numbers. Okay? And so then what we do is we just compute the determinant. Both determinants of this and divide them. Okay? So we do, to do a 2 by 2 2 by 2 determinant, sorry, that's a tongue twister almost. You do these two times each other, so -8, and then subtract these two times each other, so -12. Okay? Divided by, we do these two times each other, so 16, minus these two times each other, so -6. Okay? And so what we find out is, well, when we do -8 minus 12, that's going to be -20. And then 16 minus 6 is 10. So x is -2. Okay. So we were able to use Cramer's rule to solve for x. Okay. And I can similarly solve for y. It's a very similar process, but instead of replacing the first column with the numbers over here, I replace the second column. Okay, so we're going to have two determinants. the bottom stays the same, so 2, 6, 1, 8. But then the top, I replace the second column with -1 and 2, and I keep the other ones the same, so 2 and 1. Okay, so again, we're just taking the numbers that are here, and we're putting them in the second column because y is the second variable. Okay, and so now let's compute this out. I'll try and do this with space preservation. So 2 times 2 is 4, minus a -1. And then 2 times 8 is, we already did this one actually. The bottom one was 16 minus 6, which is just 10. Okay, so we've got 5 over 10, which is the same as 1/2. Okay, so I'll maybe put here y is 1/2. Okay. Oh, can you see that? Does not look like you can. Okay, let's adjust this a little bit. Sorry about that. Okay, I think that's better. So essentially we do the same thing with y, right? We just replace the second column with the numbers over here in our determinant. We compute the two determinants over each other, and then we get our answer. So we got y was 1/2. Okay, so this is Cramer's rule, and in this video we're only looking at it when I just have x and y, but you can actually do it for x, y, and z as well. So in the next video I'll look at a 3 variable situation, and it's pretty similar, but it gets a little bit more complicated with three variables for sure. So okay, well, I will see you in the next one.